Class example 3.2.7. Josephine leaves her home and walks to the store. After buying a drink, she slowly jogs to her friend's house. Josephine visits with her friend for a while and then runs directly home. Using the distances shown, draw a distance time graph to show Josephine's distance from her house. Explain each section of your graph. Okay, so first of all, let's talk about distance versus time. And let's think about which one is going to be dependent and independent, or the input and the output. Or in other words, which one's going to go along the x-axis and which one's going to go along the y-axis. Now, unfortunately for us, we cannot control time. Time is something that just happens. After 1 hour, after 2 hours, after 3 hours, after 4 hours, that's what we would claim is our independent variable. We have no control over it. Distance, on the other hand, we can see in Josephine's example here, our distance is changing all of the time. So it's actually like what we would call our dependent variable or response variable. And so in that case, what we're going to do is we're going to put time along the x-axis, and we're going to put distance, and we're going to put distance along the y-axis. Now, we already know that the distance from her home is what we're trying to do. So if she starts at her house, then she's going to travel 1 kilometer. Then she's going to travel another 3 kilometers. She's actually going to have to travel all 4 kilometers back home. But our graph is going to show the distance from her house. So her house is going to be here. She's going to travel a distance away from it. And then she's going to come back to her house. Okay. So if we've got this, we're going to try and create a scale along the y-axis. We're only going a total distance away from her house of 4 kilometers. So why don't we say this is 1, 2, 3, 4. And I'm going to actually put the units of kilometers right up along the side there. Now, we don't know how long she's staying anywhere. We don't know if it's hours, we don't know if it's minutes, we don't really know what's going on here, but let's just think logically about jogging, running, and buying a drink, okay? When I think about walking to the store and walking about 1 kilometer, let's say, 1 kilometer maybe between 15 and 20 minutes, okay? When you're buying a drink, you're talking about maybe 5 minutes, right? You go in, you pick your drink, you drive it. Visiting, I don't know. That could be dependent upon how well Josephine and her friend get along. And then we're talking about, again, the distance of 3 kilometers, and we're running now. So maybe for 3 kilometers, it might take, 30, 35 minutes if she's jogging, something along those lines. So I think we should go and say that we're going to deal with this in minutes, not hours. Okay. And maybe what we're going to do is we should go up by 5s. We're going to give her a short visit. Okay. So this scale of time is definitely something that you can play around with. Okay, you don't have to necessarily go up by 5s. Maybe you wanted to go up by 10s. Maybe you wanted to go by seconds and make it really fast. It's up to you. You could have maybe only put 2 hours along this clock and had in an hour, something along those lines. Time is something that, is subjective. So this is not set in stone. What we do know is that we also have 3 different speeds, okay? She walks, she jogs, and then she runs. The only other thing that she does is she doesn't move around, so she is stopped. Okay, she stops at her friend's house and she stops at the store. So when we are talking about our distance, first, from her house to the store, we're going 1 kilometer. So she's going to start with 0 distance and she's going to head up to 1 kilometer. And this time she was walking to the store. So maybe she's going to take, I don't know, maybe let's just say 10 minutes. Maybe she's a fast walker. So if she walks 10 minutes constantly to the store, then she's in the store. When she's in the store, she's not actually changing her distance from her house. But let's say maybe she takes 5 minutes to actually get there, or to pick her drink and pay for it. Okay. Next thing I see is that she's going to jog, and she's jogging 3 kilometers. So we're going to go 3 more kilometers away from home for a total of 4 kilometers. Okay. And I can see if she's jogging, then she's actually going to be faster than if she was walking. So if we said it took her 5 minutes to go half a kilometer, maybe this time it takes her 5 minutes to go a full kilometer. Maybe it's a little bit less than that. But if I'm going to go 1 kilometer in 10 minutes, if I was staying at that rate of 1 kilometer in 10 minutes, now I'm going to go 3 kilometers. It's not going to be 30 minutes, right? She's got to go faster than that. So maybe she makes 3 kilometers in 20 minutes. Okay. So if we're going to go 5, 10, 15, 20, and she's going to go all the way up to 4, then maybe we can see that that line is just a little bit steeper and she's jogging it. Okay. The next thing I know, maybe just for the sake of my map right now, I'm going to say she's not going to stay at her friend's house for very long. She's only going to stay at her friend's house for about 5 minutes. Maybe she just wanted to come and say hi really quick. And then she's going to run home. And now she's running home. So she's got to go all the way back to her house. So she's got to go 4 kilometers. She can't go 4 kilometers in 40 minutes. That's too slow. Okay, so even if she went down to maybe in 30 minutes, that might be a little bit better, but I think that if she's going 3 kilometers in 20, it's got to go faster than that. So let's just say she goes 4 kilometers in 20 minutes. Okay, so I'm going to go 5, 10, oopsies, 15, 20. I'm off my page already, and she's going to go all the way home. So I'm just going to extend that out a little bit, and she gets all the way home at a faster rate. And she doesn't stop all the way there.